Hi everyone, welcome back to the channel called Engineering Beyond Blueprints. So today we are going to talking about different type of electronic components. So basically, as you know, we do have two different type of majorly called active and passive component. So active component always requires a source of external source to activate or function those components, whereas the passive component does not need external source. What does mean? So passive components are in, like, if you ask me, there are different set of components, right? So why passive component does not need a source? So that, keeping that question as curious, let jump into the detail of what does mean passive component. So today we are exploring the fundamentals of building blocks of electronic component that do not amplify the signal, do not require external power to operate, and yet to make every component device in the world possible. So by end of this training, you will understand what each passive component does and how they behave electrically, their key parameters, and where they've been used in the real world. So this said, like with these four segments, I would like to jump over to the different set of passive components, and I want to talk about what are these different types of components and what their technical parameters. On top of that, right? So why we need to analyze all these different parameters of the passive component? The reason behind, when there is a part gone obsolete or NRND getting near in future, so we want to make sure that to keep the manufacturing readiness, we always recommend a better solution so that we should not impact any manufacturing readiness or the production gap, which is indirectly impacting to the revenue of the company. So that is where I said component engineering are the heroes behind to design any of the board, not only understanding the technical parameter, to understand what is a business case, what are the life cycle status of the component, what is the cost of the component, how long the parts will be available in the market. So with that said, rightly we can start jumping to the different types of passive component. So first comes with the resistor. So resistor is a component which uh, mostly widely used passive component, I would say. The resistor job is to control flow of current and create a voltage drop in the circuit. So that is a major functionality. This is very much basic basic functionality of the resistor, I would say. So coming to the getting to the technical parameters, I would say key parameters, right? Key parameters would be the resistance value, tolerance, power rating, temperature coefficient, noise, and maximum voltage rating. And when we choose all these key parameters from this resistor, and we want to see, when I want to recommend an alternate solution, how should I define which is a better technical parameter, which is not good or good alternate or something. So this is defines based on these technical parameters. So in this majorly, when we say tolerance, right? So if you select the component which is having lesser tolerance, always it is precise and cost effective. And when I say cost effective, this is going to be a increase in the price when compared to the higher tolerance resistance, right? So power rating always higher is better, and temperature coefficient is always lower is better, and noise also should be lower is better, and maximum operating voltage current should be at higher side of it. The application of these resistors widely used in voltage dividers, pull up and pull down circuits, biasing network, and current limiting. The resistor may look simple, but it controls stability across almost every electronic system. Now we'll get into the second type of passive component called capacitor. Capacitor stores the electrical energy in the electric field, right? So they charge, discharge, smooth filter, and stabilize the electronic devices across the board. Key parameters of the capacitor always the voltage rating, dielectric, ESR and ESL. So ESR and ESL are very much critical parameter while you're choosing the alternative solution. Leakage current also equally important, and temperature range also be an equally important. So when we talk about finding an alternative solution, the voltage rating should be at higher side of it. ESR and ESL rating should be at the lower side of it. When I say ESR and ESL, what does mean? ESR is equal series resistance of the capacitor to measure, and ESL is equal series of inductance, right? So leakage current always should be at a lower side because we want to maintain the proper current flow across the board, right? So that is where it stores the energy properly, electrical energy. So the applications, when we talk about applications, right? So this is majorly used in decoupling of ICs, power supply, filtering, timing circuit, AC coupling, and energy storage. There are multiple types of capacitor, we would say, like one is ceramic capacitor, electrolytic capacitor, film capacitor. Each play unique role. Understanding these difference essential for reliable designs, right? So next, getting to the inductor. Inductor also store the energy in the form of magnetic field, right? They resist a sudden change on current, are crucial in power electronics and RF systems. Key parameters are inductance, saturation current, rated current, DC resistance, quality factor, and self-resonant frequency. So when we say the saturation voltage and the DC current should be at higher side of it when we are selecting alternative solution, and even quality factor also should be at higher side when we are selecting the inductor. So DC resistance and self-resonant frequency should be, sorry, I would say DC resistance should be at the lower side of it, self-resonant frequency should be higher side of it. So we'll talk about in detail as time permitted all these parameters, why we choose lesser is better, higher is better as in value compared to when we choose the electronic alternative solution. The application of these inductors are used switched mode power supplies, AMI filters, energy storing inductors, and RF timing circuits. An inductor with wrong saturation current can cause catastrophic failure in power converters. This is why proper selection is matters. So when I say proper selection is matters, I would say should be equally consider the design of the board, design requirement of the board, and when we are recommending an alternate solution, these are the key parameters we need to understand and find the solution accordingly. Now we come to the fourth type of passive component called transformer. Transformer transfer the electric energy between winding through electromagnetic induction. The key parameters are turns ratio and voltage and current ratings, isolation voltage, leakage inductance, and core material which is used to build this transformer. So always we have to keep in mind the voltage rating and isolation voltage should be at higher side of it. Leakage inductance should be at a lesser side of it, right? So the when it comes for applications of usage of the transformer, we use widely in AC voltage conversions, isolations, power supplies, and audio coupling, right? The high frequency switch mode power supplies transfer design directly affect efficiency of thermal performance. So the fifth one comes as a diode. Diodes are allowed the current flow in any direction basically. So that is the characteristics of the diode. So diode is not a really a passive component, I would say. It's a semi-passive component or semi-active component. So key parameters are forward voltage, reverse voltage current, reverse leakage, breakdown voltage, and reverse recovery time. So these are the basic minimum parameters we have to choose when we are selecting the diode. So there is a question, right? Which one, when I'm selecting an alternate solution, which parameter should be a better and which parameter should be lower, and which parameter should be at higher side of it, which is better, which is not better, or so on. So given that said, when we are selecting the diode, forward voltage should be at a lower side of it, reverse leakage current should be at a lower side of it, and reverse recovery time should be at a lower side of it. And and why we should be lower side of, because recovery time is times is matter, right? So we should be lower side of it is better. So, and leakage current, reverse leakage current, I would say this should be lower side is better, because the reverse leakage current always uh, it could impact the diode characteristics, right? So we will go in detail for some of these based on the audience requirement, based on the students requirement, or based on the my peers requirement. I can share the cheat sheets for each of these technical parameters for given all type of passive component. And coming into the types of diode, rectifier diode, Zener diode, LED, and fast recovery diodes. The application mostly used in rectification, voltage regulation, clamping, protection, and polarity correction. Diodes are unseen protector of almost every circuit. Right. The sixth one, we get into the fuses and protection devices. Fuses are safety component that break the circuit when excessive current flow. As you might seen in your home or any of the places where safety is matter, when there is a high flow of AC current and there is instability in voltage of the or instability in the current, definitely fuses play a critical part when it comes for safety. So key parameters are rated current, time current characteristics are equally important, and come to the voltage rating and braking capacity is equally important. All these parameters should be at higher side is better, and lower side of it if you select definitely is going to be a safety concern across the board, right? So these fuses are first and last line of defense, preventing fire hazards of equipment to damage. Right. So these are all to protection the from the damages or from the fire of AC current flow across the board. Right. So this is where the fuses are play critical role in passive component. Now, we want to understand in general what are those five thumb rules we should follow when we choose a better alternative solution for a obsolete part number and for not recommend for new design part numbers. So basically, the thumb rule is five. The number one is form factor, footprint, and pinout is first. So if first when you choose any component, first you observe these three parameters, which is very important, because rest of the parameters, even if you see, that definitely cause for redesign if any of these parameters got impacted. Like as I said, form factors, fit factors, and footprint and pinout, right? So next come to the electrical parameter, as I said. So it depends on the design requirement. We need to choose the right component as an alternate. So yeah, for example, when you choose the capacitor, right? So or resistor, by all means, the tolerance value should be at a lower side is better, but it is equally trade-off when we select the component. Equally trade-off means what? Equally trade-off means it going to be a increase in the cost when we select the tolerance at a lower side of it. When we select the tolerance at higher side of it, cost will be less. That is a simple thumb rule when we say trade-off in the cost. So next comes how it is behave in the board, right? So when we do the reliability testing, always we want to see how reliable these component when we assemble in the board. So when I say reliable, how long this board can be sustained, like support basically, how reliable. In general word, we say what is the guarantee or warranty, we say this component can be withstand, and it provide exactly the output what we define in the early stage of the board design. So any component or any even in fact if you take as a human, like as we grow we might degrading ourselves as a component life cycle, you know, right? Always any components is built, it's coming to the from introduction to saturation and saturation to decline and decline to obsolete. Likewise, any reliability of the part number, it's gradually decline stage over a period of time, depends on the usage of the component in the board. So with that said, I hope this tutorial or the video is helpful to everyone, at least to understand what is mean by passive component. But when we say in the real world application, where and all it's used, right? The passive components are appear everywhere, right? And it's used in power supplies, microcontroller boards, communication circuitry, and automotive and aerospace. Without the passive component, electronics simply cannot function. That is the thumb rule of passive component. I hope you understand this segment, and I would like to share one given note. When we choose alternative solution, why we always say higher side of the value is better, lower side of value is better in some of the parameters, right? Why we would say? Because we had some reasoning when I say choose the better value and lesser the value and all. For that, I have a reasoning for each of those parameters. I would like to share the people who are subscribed and watch this video till the end, right? That is going to motivate me and that is going to help me to, yes, segment of this video is reached to the right people at the right time, so that this is going to be helpful for them in their career life. And not only the career life, is going to help them where they have been working, and it's going to help a lot in the future. So similar set of videos I'm going to share in the upcoming sessions, where I've been talking about now more of active components. So active component is a bigger topic. Again, to summary, I want to break down the active components by segment, and I want to walk through each of these active components in the future, and I want to segmentize those. And altogether, if you see how this video looks like, and does it really helpful to you, if help, please do say one thumbs up, so that it's motivate me a lot to come with more content towards on the active component. All the best. I hope this video reaches to the right peoples. Do not forget to put a comment and ask for the cheat sheet. Just mention with a double code called cheat sheet, so that I will share the reasoning why we want to select the higher the value and lower the value of the components when we find the alternative solution. With that said, I hope this video has helped a lot. Thank you so much for watching. Have a great day.